Hello, everyone. Welcome to this Ubuntu Masters Talk. My name is Rhys Davis. I will be the moderator for this afternoon, this evening, this morning, wherever you're joining us from. With me today, I have Benjamin, an embedded software engineer over at Bosch, and Michael, the director of product management for ctrlX World. It's a pleasure to have you both here. Thank you for joining and welcome.
Thanks for the invitation.
Thanks for the invite, Rhys. Good to be here.
No problem. Today, we will be talking about how Bosch Rexroth approaches the classic boundaries between operational technology like machine controls and the Internet of Things in the new world industry of Industry 4.0 technologies. In this session, the guys are going to explain how Bosch Rexroth approaches these problems with its new complete automation solution, ctrlX Automation, or CAPS. It's good. Which is based on Linux with real-time extensions, consistently open standards, app programming technologies, web-based engineering, and comprehensive IoT connection. This session will go on for roughly an hour, so kick back and enjoy it. The first half of the presentation will be by our guests here. The second half will be a Q&A section where I'll be asking and taking questions that you have submitted below your screen in the questions box. And I'll be putting them to Benjamin and Michael here for their answers. I just have a few reminders for everyone. So first of all, now that everyone's settling into the session is being recorded, and you will receive the recording automatically after the end of the session. So don't worry about any of that. It is being recorded. You will get it. Please check out the resources in the attachments tab. That's also beneath the screen. That's where you'll find links to more information and some things to read, maybe during or after the presentation. Probably after the presentation would be better. And also remember to join the Telegram group to join the discussions during the session and after the session, so we can continue on things there. So with all of that said, again, don't worry, the session is being recorded. You'll get it sent to you. Let's go ahead and start the presentation.
Industry 4.0 needs a complete automation solution. And we are going to present to you over the course of the next couple of minutes our approach to this, which is ctrlX Automation. So what was our motivation for ctrlX Automation? Pretty easy. When you compare modern IT and consumer technology, probably most of you are used to app stores, speech recognition, modern programming languages, version control with GitHub, security or updates, and you compare it to our operational technology world where we are coming from as Bosch Rexroth, you see that there's a slightly difference and there's a lack in technologies actually, and IT world is much more ahead. Why is that so? When we are looking into a factory of today, we see that we have these different levels, we call it automation pyramid. From the products, from the shop floor itself, over the field level, there's a control level where we usually play, a supervisionary level, planning and management. And this is the automation pyramid. And there you see the two different domains playing, the operational technology domain and the IT domain. And both came out of the 70s from the last century where computational power was really much increasing. However, in operational technology, we concentrated very much on machine and operation safety. We cannot have a blue screen on a machine, yeah? And determinism and real-time capabilities. Whereas in the IT domain, we see a lot of is going on in data security, administrability, updatability and scalability, especially with when the internet came up and then also the cloud solutions. So there are these two different worlds which really developed in a different way, but there's some reason behind, as I explained to you. So nowadays, we still have in place in factories this automation pyramid. And in the beginnings in the 70s, this was really good way to organize everything in the factory, and we had some specializations on horizontal level and adaptation, and you could really plan the production. You could really plan what you're going to produce and where and how. And now we are entering this VUCA world. And VUCA in the VUCA world is really shifting our needs for production. Yeah, you see from one day, now in this COVID time, we had a very high increase maybe in toilet paper in Germany and in France with wine, and you really had to shift the production in a very easy manner. And this automation pyramid is really avoiding this really flexibility. So VUCA world nowadays in the factory of today means flexibility in production, means transparency, what is going on, and nevertheless also speed in taking decisions. And consumer value really in this world for our customers, so the machine builders and the machine users, is really a flexible load, dynamic load balancing between factories, maybe also creating more vertical solutions, yeah? So combining technologies from different levels really to get something really new, improved quality management, of course, and the overall equipment efficiency, which is a KPI in the production world, which defines the quality of production and the speed, needs to be improved. And the IT and the OT world, really between these two worlds, there's a kind of firewall. As I explained in the beginning, two different origins, but now we see this firewall is really avoiding Industry 4 solutions really taking place. Why is there a firewall? Because in operational technologies, as I said, we have this horizontal layer which was very much optimized by many of the component producers. We find proprietary ecosystems, we find proprietary interfaces. In the operational technology world, there is still missing of data security, yeah, of the OT, of the operational technology devices like PLCs. Yeah? So we find this communication means is really isolated, and there's these control levels, we also find a lot of monolithic solutions and a missing framework really of cross-domain collaboration and really avoiding the firewall. And that's one of the main reasons why Industry 4 really took place in factories, but did not really show its full potential and could show much more today in these VUCA worlds. So we said there are needs for a new automation platform, and here you find 6 characteristics that this platform needs to be. It needs to be connective, of course. We need to have the devices connected. It needs to be secure. Security not only on server level, but security up down to the field level on the actual device itself. It needs to be hardware agnostic. So today, for example, we are binded to PLCs. The software you develop for a PLC, you cannot take and put on a server when you need scalability, for example. It needs to be administrable, meaning like servers are managed nowadays, a PLC is not managed like that. You need to go down to the shop floor, connect with a USB drive if you want to do some updates, for example. So there is no central point of where you can administer PLCs or field devices. Of course, we should not forget that we still live in this deterministic world, so we need reliable communication between devices, which is deterministic on time. And the 6th characteristic, it must be really open and extendable. And that is ctrlX automation, the smartphone of automation. It's a complete automation solution, meaning that we start on the field level with motors and drives up to controller level, where you find the ctrlX core, which is our main CPU. Main controller, I'm going to talk about this in a few seconds. A complete I/O system for catching signals like sensors and doing actuators. IPCs to do edge computing, of course also displays for controlling a machine via HMI, and a complete software world which comes with it, meaning IoT functionality, PLC functionality, motion, which you need in synchronized machines like a printing and a packaging machine, and complete operational safety. As I said in the beginning, no blue screen is allowed on the factory shop floor. And ctrlX Works is like our software platform really that fits to ctrlX core, to the hardware, and then shows its full power. Of course, when you present a new platform, customers expect that everything is smaller, and here you see some overview of the things that we have shrinked by using, for example, modern power electronics. We could reduce the size of a drive or the size of a motor, but also very much important is the way of software installation. In the automation, in the operational technology, you still have it that people need to install software on a PC in order to make, for example, troubleshooting of a PLC. Our mission here was, and again, that's something coming from the IT world, to be 100% web-based. And you are going to see the web-based system later on. Consistent performance is important, that we just have one CPU platform which can come in different housings. So you see on the left-hand side here our ctrlX drive, which is needed to regulate the motors. It comes in a DIN-rail version with the core, and it comes inside an IPC. The platform itself is the same. It contains a 64-bit multi-core CPU. There are no software boundaries between these platforms. So you develop for one platform, you develop the software, and you can use it in the different typologies. And the typology is really depending on what the customer wants to use in his final machine or in the final factory. And the software can even be installed on edge servers and virtual servers later on. Flexible interfaces, very much important. When you're on the shop floor, you need to communicate with a lot of field devices. You find here 3 Ethernet ports on the controller itself. There is, of course, the main field bus. A field bus is something that still needed to talk to many field devices. In our case, it's EtherCAT, where we talk to I/Os, to drives, to the safety, but also to any kind of other sensors. There is, of course, an engineering port and also another Ethernet port for upper level communication towards the factory level or towards, for example, the cloud. And you can extend it left and right with more connectivity features, like also SSD storage if you want to do data recording, for example. Now we come maybe to the most important part of this platform, and this is also where it plays together very nicely with Ubuntu, and one of the main big drivers which really is changing automation, and that is uniform architecture. Here you see on top of this multi-core CPU, we applied Ubuntu Core version 18. And on top of that, we really utilized all the features, all the possibilities that actually Ubuntu and using Linux in general offers us. So we changed here to Linux due to the fact that we could utilize, for example, the software container system. So everything in our control is based on app technology, and we use here the snap system from Ubuntu. Meaning that every function sits in its own snap. So there's this container host managing all the containers. And on top of that, you can find our main automation core app, which is the runtime, basically firmware of this device. And then every function that you used to have, like own devices, like a PLC or like a gateway or like a robotic control, now is sitting in all these different containers, and the complete device itself is splitted into software apps. Even the Ubuntu core is sitting in a container, so it allows us really to separate all the functions in different containers. And there's the central nerve system, which is the ctrlX data layer. We are going to see it later on, which links all the data together. So all the apps, they go to the data layer, they get their needed information. This can be real-time and non-real-time information, and they store it back. So the architecture is revolutionary in automation so far. So the controller system is defined by its software, and there are many containers already or software apps that we deliver with our control. So for example, a PLC app, motion app, different IoT apps, communication app. So the complete system here you see is just a little overview of all the apps that are available. Of course, there's the engineering apps which you need in order to engineer the system. There is a very vibrant community, online community, where we invite you actually also to join and have a look, our ctrlX automation community. And there are several management services that I'm going to explain later on. So we actually created, on top of Ubuntu Core, the most open automation system currently on the market. And we go so far that we allow to our customers to extend the system with anything which is available on Ubuntu and create apps. So for example, if a customer wants to do some very nice machine learning application, of course he can use Python and the already existing libraries and create an app with the help of our software development kit, and it can run on the controller. Or he can create real-time apps in C and C++. And developers actually don't need to use our toolchain. They can actually develop, for example, Visual Studio Code, directly apps for our platform, which is supported by the community. I told you about that. So, and also there are examples on GitHub. And if customers don't want to create apps on their own, we have a big partner ecosystem already built up around the platform. So we have companies who contribute apps to ctrlX automation. We call this ctrlX World. There customers can find, for example, AI-based production and process improvements. We work together with gearbox companies like Wittgenstein, a German gearbox company, which create intelligent mechatronical systems. We connect to IoT platforms like from 4Cam or the Bosch IoT suite. Yeah, there are many more apps to come. It is currently the fastest growing ecosystem in the automation market, and this is also due to the fact it's really attractive, but also to the platform. We want to establish also an industrial app store. Actually, it's already online, and customers can buy and download these apps. And there's a flexible update management via our device portal, which I'm going to explain just in a few seconds. So the most open automation system on the market in the world, as I said in the beginning, which is dominated by really proprietary ecosystems so far. So here, the power of Linux really helped us to really create this open automation system. And the reception on the market is really exceptional at the moment. From the IoT perspective, we concentrated very much on security. So you see here in the middle, IoT security on all levels. That means secure, the device itself is secure by default. We also make it certified. There's an integrated user and permission management, something that you from the IT world are used to, but in automation, this is rather new. And there's secure authentication also to the data layer, which is our central nerve system. On the left-hand side, you see we integrate and connect to almost everything. We basically create standard connectivity. OPC UA is the de facto standard in automation. REST API coming from the IT world, same as MQTT. And there are also some connectors for local databases. On the right-hand side, you see something really also revolutionary in automation, pretty boring in IT, cloud-based device management. So we actually allow to our customers to update, to back up their devices, their ctrlX devices installed on the shop floor. So if you are a plant owner and having 100 ctrlX cores installed in your factory, you see exactly the status of each of these controls, and you can do the updates. Like before, you always need to use maintenance personnel to do these kind of things. In the engineering world, I explained already, our target is to have everything web-based. You used to install a lot of software on engineering PCs. Nowadays, you log to the control. We are going to see this with Benny afterwards. You log to the control, and the control itself gives already all the status information. We look also very much into the topic of no or low code. So you need more and more people who need to program maybe little stuff and they are not experts in programming. So low code is really helping us there. I talked about all the languages that we support and that customers can create their own software and their own intellectual property. Big topic for us also is the topic of digital twin. So being able to simulate industrial controller without having the actual controller on the desk, very much important. And also simulation in commercial simulation tools. Then there is also automation possible of all the engineering, and as already mentioned, collaboration is a high topic for us. A community, app store, there's an online configurator. We use Git as a version control system. We publish open source code on GitHub. All the manuals are online, and there's also a very nice YouTube channel that you all should subscribe to. And yeah, maybe that's something that you in the IT world are not used to. We have to offer very long service availability of our devices. So this year we introduce ctrlX Core, our main controller, and it will be there will be still possibilities for getting spare parts and updates for the next 25 years. Meaning in 2045 or 2046, there will be still possibilities to retrofit, for example, a machine with the controller. So there's a very long availability, and but we are used to this. This is our main business, and around this, let's say standard services that you have in operational technology, we integrate a lot of digital services, be it an app where you can order spare parts, an indicator which says, oh, the device is doing good or not so good, and the device portal to manage all these devices. And there's much more around it, and it will be further extended. Also something that we learned from the IT world. So that was my little introduction to the platform of the unlimited possibilities. Also thanks to Linux Ubuntu. So we are coming from the world of machine automation, but you can use the platform also for, of course, PLCs, line controls, building automation, safety. It can be used as a gateway, as an intelligent edge device, in machine learning, and you can also call it an industrial Raspberry Pi. So if you want to develop something on a Raspberry Pi and you want to bring it to the shop floor, then ctrlX automation maybe is the best thing. You can also integrate it into devices, as you can see on the right-hand side. Yeah, so it's really up to your creativity what you want to do with the platform. And now I would like to hand over to my colleague Benny, who is giving you a little live demonstration of ctrlX automation. Benny, your turn.
So thank you, Michael, for that introduction. I now want to show you what it means like to have an app-based automation system with web-based engineering in a live demonstration. I've connected my ctrlX Core to my laptop, and I can now access it just using my favorite browser. So I open the browser, and it's connected to my local network, so I can access the ctrlX Core with a local IP address. I type in my password, and then I get to my home screen. This is the main dashboard you see when you connect to your ctrlX Core. On the right-hand side, you can see we have some product documentation, we have the API reference, and we also have a link to our great developer community, which Michael already mentioned. If you're familiar with Linux, it will be very easy for you to configure your control. When you go to your settings, you will find settings like connectivity, where you can configure your network interfaces like IP addresses, and also date and time, users, groups, and permissions, and all the stuff you know from your standard Linux environment. Talking about an app-based environment, we also have a menu entry here for apps. In this case, on my ctrlX Core, I already have a Motion app and a Node-RED app pre-installed for this demonstration today. Adding a new application to your ctrlX Core is as easy as clicking on local storage here and uploading your application with this plus button here. Another unique feature that I want to show you today is the ctrlX data layer. The data layer is for accessing and exchanging information between applications on your ctrlX core. Having a look at the data layer in the web UI presents you a so-called data layer tree with all the information that is stored in the data layer. As I have the motion application already installed, there is some motion information in my data layer. I can click on motion and, for example, there is some information about the configured axis here. Clicking on the axis will show me no axis yet is configured in my system. So I can go to my motion application and creating a simple axis called axis demo in my motion application. Now this axis was added successfully to my motion application, and going back to my data layer will show that I find this information also in my data layer. So other applications can retrieve this information from my motion application by plugging into the data layer. Data layer is accessible using C and C++, and Go and Python will be there in the future. And also open standards like REST and OPC UI can be used. So, simple example for REST. On my desktop, I have installed Yark, yet another REST client. Most of you will probably know this one. And I have configured some favorites here. For example, a motion access request. This motion access request is just a browse to my path/motion/access. And once I send this request to my control, with the right authentication of course, I can here see in my response body that the access demo was responded from my control. So I can use any REST client, or I can develop any REST client and access data from my data layer. It's as easy as that. The same applies to adding new access. So in this case, I have a post request over to motion access, and I'm giving a value, for example, access demo REST. I'm sending this to my control and I get a HTTP 200. Looking into the backend of my control, when I go to my motion access configuration, I can see the access demo REST was created here. That's pretty awesome because you can use all these open standards to easily configure your system. But how about you want to do more than just creating one access using REST? So you can use all the tools you like, and you can use the programming languages that fits your purposes best. So for that, I will just clean up my motion, deleting my demo access, and I want to show you a complete example on how to use, for example, Node-RED to have a complete robot in motion. So for that, my colleague provided me a Node-RED flow, which I have on my ctrlX. So in this flow, you can see we have automized all these steps that I just did first manually, then via REST. Now I'm using a Node-RED flow. I'm creating 3 axes, I'm creating a robot, I'm adding the axis to the robot, switching a motion to power, and then I turn on the robot and move it. I also have a flow to jog the kinematics, and just for demonstration purposes to move the axis of the robot to a specific value. So I'm deploying this using Node-RED to my control, and now I can switch over to my dashboard. Going to my dashboard, I can see all the functions that I have just shown you are here as buttons, so I can just click on Create Axis, and I define 3 axes X, Y, and Z in my system. Going back into the backend and refreshing my motion page, I can see from the Node-RED dashboard my axes X, Y, and Z were configured. In the dashboard, I go further, I create a kinematic called robot, I add my axis to this kinematic, my motion goes into state running, and then I power on my robot. Now I can see the axes X, Y, and Z are in standstill, and now I can group these together so I have a coordinated motion of my robot. All these using just my simple Node-RED workflow. Going into the back end and having a look into my motion. So I have the kinematic commissioning here, and I can see that my robot was created, it's powered on, and it's grouped together. The X, Y, and Z axis has a value of 0 right now. I could now use the control down here to jog my kinematic. For example, if I want the x-axis go to the value of 1. If I click on the plus, I can see that my robot is moving and the x-axis moved to the value of 1. But we also have a Node-RED dashboard for that in the demonstration. So going back to the dashboard, I have a Move Kinematics dashboard. And here you can see on the right side, we have some graphs which show the current position of your robot. The x-axis already moved to value of 1, and I have my fixed positions 1, 2, and 3 for demonstration purposes in my tool. So if I click on position 1, I can see that my robot moves and all 3 axes are showing here in the graph. Also in the backend, if I refresh the page, I can see that my position here is moving. Just as easy as that, you can configure your ctrlX automation project just by using open standards. Thank you for your attention.
Thank you both for that. It was a really interesting presentation. I especially very much enjoyed the demo. I've seen those slides before, so nothing terribly new, but that was really good. Thankfully, with my role as moderator here, I get to ask my questions first. But I'll try and keep it within some limits so we get to some audience questions. I just want to have a quick reminder to the listeners there now that everything you've just seen will be recorded and will be sent out to you once all of this is done. So first question that I had, and I feel like I have to ask this one, is why did you choose Ubuntu in the first place? Or more specifically, why did you choose Ubuntu Core for this platform?
Yeah, that's a very good question. Wies, I didn't expect you to ask me this question.
I'm sure.
I think we are very happy with Ubuntu and the possibilities that come with it. One thing for sure is the security stuff that is already included in Ubuntu, which by no means was a standard in automation before. So we really utilize your security features, and of course also the updates we get with the long-term support of Ubuntu Core. But another thing is, and I think we explained it in a very much in detail, the Snap technology, the container technology, which is really revolutionizing automation. Yeah, you get one hardware and you say, this is a PLC controller just due to this app. This is a robot controller just due to this app. Like before, really, you had to buy different devices and different things. So it's a software-defined controller, and this is due to the fact that we have these software containers. And maybe Benjamin could also add some facts, because he's really touching Ubuntu Core, what he really likes about it, being a developer.
Yeah, so basically what you already said, the Snap ecosystem is a great feature for us developing new application, and having like this open system is also something that not only Bosch developers, but we also see from other developers that start using the ctrlX, that they really like to develop their snaps, because this is a technology they already know. And also updating our control using the Snap technology is a good feature. That's why we have chosen Ubuntu Core.
I mean,
That's
by no means, Reese, in automation, as I said it in the presentation, this is not common to have software containers. This is not common to do updates on machines that are running. So it's really a change of paradigms in an industry which is very, let's say, conservative. But I think now is the time really that these standards are so well developed in the IT world to bring them to automation as well.
Indeed, that's great. I mean, I'm a big fan of snaps myself, but you probably could have guessed that. I also feel like I have to ask as well, while I've got you, how are you seeing the market react to this product, having Ubuntu on the shop or the factory floor, and what's the initial impact like?
Yeah, I feel the initial impact is great. We are on the market now roughly 1 year. The feedback has been really great, and especially about the possibilities that you can do with the system. This extendability with own functionality is amazing. So in fact, to be honest, we are just launching our embedded controller that you put on a DIN rail last week, and we had some demo units before, like 100 demo units, and they were constantly borrowed by some customers and who were doing some tests. So we are now happy that we are in open sales and that we can finally ship the product, the DIN rail version, and to satisfy the market needs. So it's been fantastic, and people really like this change, open source approach, open standards.
Great, that's good to hear, and congratulations in that case. That sounds like it's doing well. There was a question from the audience that matched one of my questions I had actually, so I'll ask that one next. Did I get this right? Are you using Ubuntu Core for real-time operations? How are you doing that?
Yes. So basically, the question stated it right. Ubuntu Core is no real-time operating system. That's why we're snapping our own kernel. So we're maintaining our own kernel. We're using the vanilla kernel from kernel.org, and we are applying the canonical patches to have all the security features of Ubuntu Core plugged into our kernel, and we also add our own patches. And on top of that, we're adding the preempt RT patch to have the real-time capability on our system. So we're using Ubuntu Core as a real-time operating system, which is unique here in the automation world.
Indeed, sounds good. Is there more information about that somewhere that you can point us towards, or is that under wraps still?
No, we have a community, online community where you can actually participate, get some how-tos, download a virtual control to play around with. So we sit on the open approach. But as Benny said it. I think it's time to use more Linux in real-time operations. There's even an organization dealing about that. It's called OSATL, Open Source and Automation. And we just really have so much benefits coming from a very closed real-time operating system world with the prior system that we were using. So very excited as well on the possibilities here. And so far it's doing great at our customers.
Great. Okay, good. I saw in the presentation you spoke about GitHub pages, and you talked about people working on a Node-RED integration. That looked really good. What's your plan? What's your thinking towards more things like that? You mentioned your colleague put together the Node-RED one, Benjamin. Is there anything else like that that's in the works? What can we expect for that sort of developer community going forward?
Yeah, so basically the community develops very well, and we see that all the feedback we get from the demo customers, and now that we ship the device, we get the feedback from there. There are almost unlimited possibilities you can do, and every day we learn new stuff, what customers want to do with our control and how they want to integrate it. So yeah, the community is a great way to exchange these new technologies, and yeah, it's an exciting time.
And Node-RED will become an official app on our platform that you can download from our app store. as a customer, and you will find also specific nodes for our system for Node-RED in our GitHub account. So you were asking about GitHub Ries. So we have a GitHub account where we plan to publish more software under open source. And now the first thing is the Node-RED branches for ctrlX automation being open source and publicly available on GitHub.
I noticed those. I noticed those a couple of days ago while I was poking around. It looked really good. That's actually one of the questions we had was about app stores and app ecosystems. Can you talk around that a little bit more? So
it's funny. You seem to know German, Ries, because the question was put in German into the system.
Oh.
or somebody helped you.
Maybe? I don't know.
So yeah, thanks for the German question. We understood it. Yes, indeed. We are building up an app store. The app store consists of our own apps, but we plan to integrate also open source apps. And there are, in fact, a lot of partners who want to contribute to our ecosystem. So be it startups from the AI world, be it the Gearbox company, Wittgenstein, be it HMI solutions. So we feature these third-party apps as well on the App Store and really hope to create a very thrilling ecosystem of possibilities. And really, as I said it in the video, if you are a developer, the biggest hurdle today is how to get, if you have a factory solution, how to get inside the factory, because people won't accept you, for example, with prototyping hardware. And we see as a real big benefit for the developing community. If you have a great idea, you are a developer, you can actually utilize our surroundings, our hardware platform, but you can put your idea on in the form of a snap into an app and distribute it via our app store to professional users in the shop floor. Yeah, so this still is a huge hurdle for startups to enter shop floor, and this is a great way that we are offering.
And you have that testing infrastructure in place, right? So
yes, there is a testing. There is the community. There is a testing infrastructure behind from our side. Of course, we need to test the apps in order also to that our customers can be sure that it's running well on our system, and we do that. But yeah, the possibilities are great. So, for example, there's a smaller startup from Berlin, two guys. Their name is Conductive AI. They are having a little but very impactful AI platform for the semicon industry, and they have the possibility really to go to the shop floor with our controller, and that's a great thing. I believe I'm very excited about this ecosystem because I believe there will be really nice, cool solutions pretty soon entering the shop floor.
Yeah, it sounds like, especially with something like that. That's Conductive AI for everyone listening. Go and have a look at what they're doing after this. That could be interesting.
I heard that they are looking for developers as well. I saw on
there we go. This could be the right audience. All right, so that's all of the questions that I had researched and all of these things, and we're running relatively low on time, so I'll move over to the question section here. It looks like we've got a lot coming through. The first one I see here is, hi all, hello. How are you dealing with huge amounts of data generated by the apps, attaching an NAS, a NAS, or connecting to cloud storage?
Yeah, so basically we have the possibility to enhance the storage of the ctrlX core with an SD card. So there you can increase the internal storage. Currently, we don't have any plans to integrate a network storage or something like that.
We will have a version with an M.2 interface where you can connect SSD drives, for example. Yeah, this is on our roadmap because we see that there is a need to store data locally on the edge and not putting everything to the cloud. So, for example, we said there's a data layer having all the data, and we have some customers who say, oh, that would be really nice to have a kind of flight recorder, right, of what in my machine is going on, and if there's something happening, I can go back in time and make a root cause analysis. So for this, you need data storage, and as Benny said it, SD card is the first step, but an SSD drive via the M.2 interface is the next step for that. And of course, also the system, we showed it, there are versions for the DIN rail and for an IPC, and we are also planning to have a virtualized version which runs then on a bigger server infrastructure or on-premise infrastructure, and to have a kind of controller for a line or for a factory even. This is our vision. The architecture really opens this possibility, really gives us this possibility also thanks to Ubuntu.
Definitely, that sounds good. So you're looking at a stack from virtual servers down to your local storage SD cards, maybe for a bit of black box kind of storage. Yes. Sounds really good. Okay. Next question. How about the power consumption in IoT technology, which it was implemented in a remote area? It gets a problem if the power consumption is too much. How do you address the power consumption issue with this platform?
Yeah. So. I think the power consumption of the ctrlX core, as you have seen it in my demo, is below 8 watt. So the power consumption is pretty low for such a control. So it should also be fine for remote area.
Fair enough. Nice.
And we use a ARM multi-core processor optimized also for, let's say, embedded uses like in the servo drive, and power consumption is a thing, but but mostly, to be honest, our devices are installed in a cabinet, electrical cabinet. But there are more and more, let's say, mobile applications as well. People thinking about it, as we saw on one of the slides of the possibilities. And so if there's this power consumption question, if you want to have further info, let us know. Maybe you have a very nice mobile application where we can talk about. That would be funny. In fact, there's a project where we talk about also in agriculture some harvesting machines at the moment. So that's quite interesting.
And we also currently have a student project running where a student is looking into having the ctrlX core powered by a battery. So if you have some plans or ideas for like remote area or mobile usage of ctrlX core, feel free to join the community, and maybe there's some exchange on that topic there.
Very nice. That So you had the little ctrlX core there in your demo and the student projects, and people can access them remotely through your sort of virtual infrastructure. Is there any plans in the future, maybe once this is a huge success, to have these sort of things more available to the community so people can get the ctrlX cores and play with them at home kind of thing?
Yeah, you can already get it now when you go to our community and say I want to have the virtual controller for my PC. You can install it on your PC, and the controller itself, as I said, is now in open sales. You can also buy one from us, and it's not that expensive as you would expect. This is really quite good pricing, I would say, and later on, let's see what our ideas are coming up in developer challenges and stuff like that. So we have some ideas in mind for the developing community, and we would like to execute this next year in 2021. So stay tuned and listen. Maybe subscribe to our channels.
I know I will. That sounds exciting. It sounds good. I like that. A nice little plug at the end. So
we will also get you a core Reese, and you can install a Pi-hole on it, as you are an expert of this.
as the folks will see tomorrow, I'm sure.
Yeah.
All right. Just looking in the questions section here. There's one question that just came in. Do you have any form of integration with I'm not sure if I'm saying this right, the BASys, the BASys from Fraunhofer? First of all, do you know what that is?
I actually don't know it.
Okay.
Is it a question from the chat?
It is, yes. You can jump in there and have a look.
From Fraunhofer. Oh. And
yeah,
I didn't get your question, to be honest.
Fair enough. Never mind. It looks like we're running out of time anyway. So I'll just finish by sort of wrapping things up here. Thank you both for joining. Let me just reiterate how interesting and good the presentation was. Like I said, I really enjoyed the demo, and I hope everyone here enjoyed it too. Thank you for everyone who's watching. Thank you for everyone who's watching after the live event. The recording, once again, will be sent to you automatically if you are watching it live, so you can go back and listen to their wonderful voices over and over again. You can visit ubuntu.com/masters-conference to view this session and any past sessions that we've run for the Ubuntu Masters before. And I hope to see you again in some other of the Ubuntu Masters sessions, either today or in sessions in the future. And I think that is all I have to say. So we can wrap up here. Thank you again for joining. Thank you for the presentation again, guys, and answering the questions.
Thanks for
Thanks.
having us, and thanks for the organization by you and also your colleague Anastasia. Thank you very much.
Yes, great job to Anastasia. All right. Thank you, everyone. Have a good rest of the day.
Have a good rest of the day as well. Thanks.
Bye. Thank you.
Bye
Bye.
from our side. Bye-bye.